Hello again, everyone. So we're continuing the conversation on chemical reactions and how their kinetics work. And our next stop is how do conditions, the different conditions, affect a chemical reaction and specifically the rate of a chemical reaction. So there are a couple things that we can vary, and we've already mentioned it in the prelude, and that is, of course, reactant concentrations, temperature, and the presence of a catalyst, and also technically the phase in which a reaction can take place. But the ones that we will look at specifically are reactant concentrations, temperature, and the presence of a catalyst. So the basic idea here is if we increase the concentration of a reactant, then the rate also increases. And that should inherently make sense. If you have more reactant in a beaker and in other words, there's more molecules to react, you inherently increase the reaction rate. In other words, if you give more petrol to the car, then the car will go quicker. So you're increasing the speed of the reaction. Okay, so that is what concentration implicitly does. And we're going to look a lot at how concentration influences reaction rate, and specifically how the rate is directly proportional to our concentration, reactant concentration, Right, so think of it in terms of if you have more molecules, then more collisions are possible, more of them will have the correct orientation, they'll have the average kinetic energy. If you have more molecules, then literally the higher percentage of them, the percentage-wise, more molecules will have enough energy to react. But we'll also look at that at a later stage. So that's why if you have more molecules, then just meaning percentage-wise, enough of them will have enough energy to react. Chemistry is all about percentages at the end of the day. So increasing the concentration increases our rate. Increasing the temperature will also allow reactions to occur more rapidly. So that means if we think about that, we need molecules to have a high average kinetic energy to actually react. That's a point we'll look at detailed later, but meaning that they actually need to collide with one another. They need sufficient energy then to collide with one another for these collisions to actually happen. And hence, if we give them more energy by giving them, let's call it temperature, giving them energy, hence then we will increase the rate, right? So that is exactly what the temperature does. So by increasing the temperature, we increase the rate. Okay. The final thing that we can do to increase the reaction rate is to introduce a catalyst. So if we think about, so the other two things I can kind of explain, but a catalyst is a substance that accelerates a chemical reaction but is not themselves consumed. So now, catalyst, maybe you've heard what a catalyst is before, but catalyst is something that actually lowers the energy required for a reaction to take place. And you've noticed I've mentioned the energy quite a number of times. So meaning that if you lower the energy required for a reaction to take place, and so that's what the catalyst does. The catalyst says, you know what, you don't actually need this much energy for the reaction to take place. You need, let's say, 75% of that. Then on average, more molecules will have enough energy for the reaction to take place, and hence you increase the rate of that reaction. All right, and that's how catalyst increases the rate of our reaction. The last thing is something called surface area, and that's the question of if you say, for example, have a reaction taking place in two phases. So you have solids and gases reacting, or mist and something else. Then it depends on how much surface area does your solid is your solid able to come into contact with your liquid or your vapor, or like your liquid or your vapor. So if your particle is very small, then you have a lot of particles, and there's a lot of surface area that it has your reaction can take place on. So meaning if you have a lot of small particles, then you have a lot of surface area, and hence there's a lot of small places where the reaction can take place, and hence you can think of it, a lot of mini reactions can take place, a lot of collisions can take place. But if you have a big homogeneous surface and you need to kind of wait for one thing to happen before something else can happen again, you decrease the surface area, and hence you decrease your reaction rate. We're not really going to look at surface area, but you can just remind yourself that depending on the surface area is something that you can also control. And surface area is to do with, if you have more particles, then it increases the surface area because it allows for more places, meaning literally surface area, more places for the reaction to take place. So that's kind of like increasing the concentration of the reactants when they are all in the same phase. It allows for more places for the reaction to take place. Instead of, say for example, you only have one layer or one place where a reaction can take place, so you constantly have people waiting in line. So those are options or ways that we can increase it. Is the concentration, the temperature, presence of a catalyst, and surface area. And presence of a catalyst is probably the one that's newest to you, but the other ones you kind of can control as they are. All right, thank you for watching, and I'll see you in the next video.